length coding RLC addresses interpixel redundancy, reduce the size of a repeating string of symbols that is run. Here from here 1, 5, 0, 6, 1, 1. From here a, 3, b, 6, c, 2. That means 1, 2, 3, 4, 5. 5 times 1, 0. 1, 2, 3, 4, 5, 6. 6 times 0, 1 times 1. Here 1, 2, 3, a 3 times. 1, 2, 3, 4, 5, 6. B 6 times. C 2 times C. Encode each run as single count, for example, using 2 bytes, assuming 0 less than equal symbol, count less than equal 255, using Huffman or arithmetic coding by treating them as new symbols. Lossy methods taxonomy. Lossy coding technique: source coding, block truncation coding, lossy predictive coding, DPCM, ADPCM, delta modulation, transform coding, TFT, DCT, or Hadamard, subband coding, subband wavelets, fractal coding, vector quantization. See image compression techniques paper. Lossy compression: transform the image into some other domain to reduce interpixel redundancy. Input image n cross n, construct n cross n subimages, forward transform, quantizer, symbol encoder, compressed image. This T compressed image, symbol T encoder, inverse transform, merge n cross n sub-images, some images. Example: Fourier transform: f of x y equal to 1 by n, summation of u equal to 0 to n minus 1, summation v equal to 0 to n minus 1, f of uv e power j 2 pi f ux plus vy divided n x comma y equal to 0 to n minus 1, 0, 1 up to n minus 1. Note that the magnitude of the ft decreases as uv increase. K is less than n. Here f cap of xy equal to 1 by n, summation over u of 0 to k minus 1, summation over v equal to 0 to k minus 1, f of uv e power j 2 pi ux plus vy divided by n, x comma y equal to 0 to n minus 1, summation over x minus x comma y of f of cap of xy minus f of xy whole square is very small. What transformation can be used? F of xy equal to u equal to 0 to summation over n minus 1 and summation over v equal to 0 to n minus 1, t of u comma v, h of x y u v. Various transformation t of uv can be used. For example, TFT, DCT, discrete cosine transform, KLT, Cohen loop transformation, principal component analysis, PCA. JPEG employs DCT for handling interpixel redundancy. DCT, discrete cosine transform, forward and inverse. For forward, C of uv equal to alpha of u, alpha of v summation over x equal to 0 to n minus 1, summation over y equal to 0 to n minus 1, f of xy cos 2x plus 1 of u pi divided by 2n, cos 2y plus 1 of v by divided by 2n, u v equal to 0 to n minus 1, inverse f of xy equal to summation over u of 0 equal to n minus 1, summation over v equal to 0 to n minus 1, alpha of u alpha of v c of uv cos 2x plus 1 u pi divided 2n into cos 2y plus 1 into v by 2 divided by 2n, x comma y equal to 0 to n minus 1, alpha of u equal to root of 1 by n if u equal to 0. If u is greater than 0, root of 2 pi n. Here 1, here double. If u is greater than 0, if equal to 0, 1. Okay, here alpha of v equal to if v equal to 0, that time root of 1 by n. Same. If v is greater than 0, root of 2 by n. DCT continued under basis functions for 4 cross 4 image, that is cosines of different frequencies. DCT under continued DFT, WHT, TCT. Using 8 cross 8 sub-images yield 64 coefficients per sub-image. Reconstructed images by truncating 50% of the coefficients. DCT is a more compact transformation. TCT, here TFT, WHT, TCT. RMS error, sub-image size selection. Sub-image size for DCT, for WHT, for FFT. In x-axis 22, 248, 16, 32, 64, 128, 256, 512. In y-axis root mean square error 2, 2.5, 3, 3.5, 4, 4.5, 5, 5.5, 6, 6.5. Reconstruction at 8.5, truncation of coefficients, original 2 cross 2 sub-images, 4 cross 2 sub-images, 8 cross 2, 8 cross 8 sub-images. TCT under continuation. TCT minimizes blocking artifacts, that is boundaries between sub-images do not become very visible. DCT minimizes blocking artifacts, that is boundaries between sub-image do not become very visible. TFT has endpoint periodicity. DCT has 2 endpoint periodicity. Here discontinuity, boundary points. This is the boundary points. Discontinuity from here to here. Coming here like this. Then boundary points start from here. Then start, it is come to here only, but here it will start other. So here discontinuity, boundary points is there. Here also same. Discontinuity n, this distance is the n. Okay. Here endpoint periodicity in TFT. In TCT, Fourier transform like this. In cosine transform, 2 endpoint periodicity from here to there 2n. Okay. JPEG compression became an international image compression standard in 1992. JPEG compression Source image data 8 cross 8 blocks. Forward discrete cosine transform. JPEG encoder. Condenser. Entropy encoder. Under condenser table specification. Under entropy encoder table specification. Separate table specification. After JPEG encoder given to compressed image data, then return again given to compressed image data to JPEG encoder. Here entropy decoder, and then for this table specification, then decondenser table specification, inverse DCT, then reconstructed the image data. Here decoder, not encoder. JPEG steps divide image into 8 cross 8 sub-images. For each sub-image to shift the gray levels in the range -128 to 127. Reduces the dynamic range requirements of DCT. Applied DCT yields 64 coefficients. One DC coefficient f of 0, 0. 63 AC coefficients f of u, v. Example, original 8 block. 1 2 3 4 5 6 7 8. 1 2 3 4 5 6 7 8. Here shifted block. Here block after FDCT equation 5. -128, 127 DCT spectrum. The low frequency components are around the upper limit left corner of the spectrum, not centered. Here JPEG steps. Fourth point, quantize the coefficients, that is reduce the amplitude of coefficients that do not contribute a lot. CQ of UV equal to round of C of UV divided by Q of UV. Q of UV equal to quantization table. Quantization table. Computing Q of ij example. Quantization table Q of I, j. I at I j. I in one parenthesis, j in the another one parenthesis. For I equal to 0 to n, for j equal to 0 to n, Q of I, j equal to 1 plus I plus j. Conversion quality end j end I. 1 is less than or equal to quality is less than or equal to 25, best low compression. Here this side 25 side, here worst high compression. Condensation table quality equal to 2. Example continued. C of UV, here Q of UV, and C of UV block after FDCT equation 5. CQ of UV equal to round of C of UV divided by Q of UV. Here condensation. CQ of UV block after condensation equation 6. Small magnitude coefficients have been truncated to 0. Quality controls how many of them will be truncated. JPEG steps 5th. Order the coefficients using zigzag ordering. Order the coefficients using zigzag ordering creates long runs of zeros. That is ideal for run length encoding. Block after quantization equation 6. Horizontal frequency DC AC 01 up to here AC 07. Horizontal frequency in x-axis, y-axis vertical frequency. Here AC 70, here AC 77. Here AC 01, 07, 70, 77. Like this going. Right.